Direct our Uihlein Maple Research Forest up in Lake Placid, New York. So northern New York, colder climate. Just as a little connection to Wisconsin, the Uihlein Forest, named after Henry Mildred Uihlein, that donated the property and some initial funds. And Henry Uihlein was part of the Uihlein family that owned Schlitz beer. So there's a little connection to Wisconsin there. Um, so with that, at the forest here, we're tapping close to 7,000 trees. To kind of answer your poll there, we are still in production mode. I just actually boiled syrup today. We're actually cold today and tomorrow, but I had sap saved up in a chiller tank. So with there, we have a commercial maple operation and do a variety of research and some that we'll talk about today. But Tony had asked me that kind of go over talking about the science of maple sap flow and then talk about the Maple Climate Network, the sensor system that we're working on. And so, having a little more, hopefully this will give a little more in depth into understanding kind of how we can get sap flow from a maple tree and why that's unique. And it is, I think, pretty phenomenal to think about that we're able to collect all of this great sap from a maple tree overall. And so, what is kind of required to get sap out of a tree? And I think we all know the basics that we need that freezing and thawing temperatures in order for sap flow. But to really get into understanding the science of sap flow a little bit more, I think it's kind of helpful to think about more of the anatomy of the stem of our trees to understand that a little bit more. And then we'll delve into this a little bit more later on. But overall within our tree that um, we have our bark, obviously, on our outside. Our bark is actually made up of the outer kind of corky bark. That's our protective layer that keeps the moisture in, protects the tree. And then the inner layer of the bark is actually our phloem. The phloem is what is really important for sap transportation during the growing season. Now that's not true, and that's not the case when we're collecting maple sap during our dormant season, during the maple sap season. But during the growing season, the sugar is actually moving through the phloem, which is just inside that bark. And then we get into our primary wood, which is called secondary xylem. So all the xylem, which in the growing season is transporting more water and nutrients, but when we're tapping our trees in in the spring, late winter, this is actually where we're collecting the sap from. And so the sugars that are generally in this phloem actually move in to the xylem cells through what are called these ray cells, which are these kind of horizontal cells that kind of radiate out from the center. And that's what typically allows us to split firewood a little bit easier, is down along some of those ray cells. So that those ray cells allow this transportation between the phloem and xylem to store the sugars. As starch typically inside the stem, that will then be collecting as sucrose as it's converted from starch into sucrose later on. And so that's where we're collecting that sap from. We're going past the phloem when we tap a tree and collecting from in the xylem. And just between the wood, the xylem portion, and our phloem is the vascular cambium. That's where all the new growth. So when we have new layers of wood being put on each year, that's being formed by the vascular cambium. So we definitely don't want to try to damage that. And so again, looking at, a cross section of a tap maple tree, we can see these, roll tap holes that are clearly, we're getting into that xylem area. We're past the bark when we're tapping those trees. So thinking about sap flow, I want to start with just a very basic, simplified version, which some of you may understand, and then we'll get into the little more in-depth science aspects of it as well as what we understand. And we have a better understanding thanks to some research done in the last 10 years that have helped to answer some of the real aspects of what accounts for what's created and allows the sap to flow out of our tree. So as we said, we need that freezing and thaw cycle. And when that freezing at night creates a negative pressure within the stems, the trunk of the tree, and that allows the tree to pull in groundwater. The groundwater picks up all the stored sugars within the roots, the trunk, and even up in the branches. So it moves up the tree. So this negative pressure allows that sap to flow up. And then when it warms and thaws, there's positive pressure created within that tree that pushes that sap down. And when we have a tap hole in our tree that we've drilled, then that sap naturally wants to flow out of the tree because the atmospheric pressure outside at our tap hole is less than the pressure inside of the tree that's created when we have that thawing period. And that's why when we put vacuum onto tubing systems, and the higher we keep the vacuum, generally the more sap that we'll get. And that's because we've created now this artificial ambient or atmospheric pressure that's now this negative pressure that'll allow even more sap to flow from those trees because there's a greater gradient that's created when that vacuum is put on. And we see that most, especially if you've got a couple days where it hasn't frozen at night and the sap continues to flow, and on those vacuum lines, we continue to get the sap even longer. And so um, these are showing in a couple different trees, these gauges, these positive, negative gauges on the left-hand side. At 9 o'clock right here is 0, and we can see that the dial is dipped down into the negative aspects. So that's when it was going into freezing mode. Negative pressure was created. And on the right here, the 0 psi is right here. So to the left is vacuum, to the right is positive. And we see that we're almost 25 pounds per square inch of pressure created in that tree when it thawed out. So which is pretty incredible to think that you can get, upwards of 25 pounds per square inch of pressure, close to a car tire pressure in that tree that's wanting to push that sap, and so it wants to come out. So why does that happen? So thinking about the simplified version is that there's gas within the tree, and when it gets colder, that gas is going to restrict a little bit. And those gases are mostly CO2. And so those gases restrict down, and that creates kind of that negative pressure that creates room for that sap to then move up into those areas and will freeze there potentially. And so that's that negative pressure that's moving that up through the stem. If we're imagining this is a cross section of a stem and these are cells with a gas inside. And then when it thaws out, that sap thaws, the gases expand, and that then pushes the sap back through the branch, down your trunk and out into your sap collection tubing or bucket in this particular case. So that's the really simplified version. And to demonstrate this is actually a time-lapse video, which I think is actually really cool that my colleagues, Aaron Whiteman and Steve Childs, who's now retired, but who work within our other Cornell Maple Forest, the Arnott Forest, so more in the Finger Lakes of New York State, did this time-lapse. And so I'm going to play this in a minute, but notice that we have a bucket that's going to be collecting sap. They dyed it blue to try to be able to see it a little bit better in the bucket. So you'll see that this is going to fill up a little bit as the sap flows. We'll notice this big pressure gauge, dial gauge in the center. So at 12 o'clock on this gauge, I believe is 0 psi. Anything to the right is positive pressure. Anything to the left is going to be under vacuum. We look at the digital display here. The 750 is referring to the time of the day, time of the morning. Bottom left-hand corner is the temperature, and this is referring to the humidity, so we won't pay attention to that. But if we watch this temperature and watch this dial primarily, and we see that it's 29 degrees Fahrenheit, so if 12 o'clock is 0, we notice that we are in a vacuum stage. And so as I play this, pay attention to this dial moving as the temperature changes. So we're starting to warm up, and then there you can see the gauge shoot up as we create pressure within that tree. Our bucket's starting to fill up with sap here on the right. It's about 5 o'clock at night now. The temperature is starting to drop, 32 degrees. The pressure is slowly dropping, and then boom, all of a sudden we see it go to a vacuum stage pretty quickly there. As it's now 24 degrees. Vacuum backs off just a little bit as we get colder, and everything's kind of frozen up more within the tree. There's the moon tracking over. It's down to 20 degrees, so it got pretty cold that night. Overall, sun's coming up. Starting to warm up now. And there we see the pressure start to go back up again as we get warm. And you'll notice that it wasn't like as soon as it got above 32 degrees that the pressure starts to shoot up and that there's a little bit of pause. And we see the pressure dropping down as we're getting cold. 28 degrees, and now we go back into a vacuum state. Pressure or the vacuum lets off a little bit. And we start to warm up, and the video ends just right before the pressure starts to shoot up. But you'll notice that like right now it's saying it's 45 degrees and the pressure hasn't quite gone up yet. And that's because what really dictates the sap flow is more the branch temperature, not the temperature down 4 feet off the ground with the sun hitting maybe this temperature gauge here that's going to dictate, but it's more about what's happening in the branch temperature on the top up in the canopy. So ideally for this video, we would have had more of this temperature gauge way up in the canopy attached to the branches, not allowing the sun to hit it. But I think that video really captures kind of that pressure gradient change within the tree. So hopefully you found that comment informative. So if we think about what's really happening, so that, obviously we know there's this positive negative pressure that's created within there. We can track that through different sensors and things like that. And so I explained that really simplified, that there's gases that are kind of shrinking down. But if we think a little bit more about what is actually happening within the trees, and so it gets a little bit deeper into the science here. And so if we now actually zoom in on a more of a microscopic level to look at the anatomy within the wood or within the branches primarily, but also the trunk of the tree, the branches of the tree. And so I talked about there's the xylem. The xylem was the wood structure, the primary wood structure that's there, all secondary xylem, and that's made up of all kinds of different cells. And these are kind of mostly longitudinal, kind of long, narrow, tube-like cells that are stacked on top of each other. There's a bunch of tubes stacked on top. And there's a few different types of cells. The biggest ones, and we can see in this cross section on the right-hand side, the biggest ones are called vessels. That's where a lot of your sap is going to be moving up and down throughout the stem, the branches, the trunk of the trees through these large vessels. But there's some parenchyma cells around these blue ones. There's tracheate cells, the orange, but the one I want to point out is the fiber cells. These fiber cells are the brown ones that kind of surround the vessels. So those are the two we want to focus on. Here's looking at it closely, where we have these vessel cells that are larger, and then we have these fiber cells that run up against the vessel cell. So these are going vertically. And again, this isn't showing, but as we saw before, that there are these ray cells. They're the ones that are more horizontal, that transport across some of these cells and from the phloem into the xylem. So those are in there as well. But we're focusing right now on these large vessel cells and then the fiber cells that kind of surround the vessel cells. And there's a couple papers out there. I put the citation here of what was in the Maple Digest, which was kind of a simplified version, but there's also the more scientific paper here that looks at, and it was able to mathematically calculate and field tests at the Proctor Maple Center, looking at uh, the actual sap flow and line up with their mathematical formula to find how this pressure is actually gathered within there. And so the big way of how this pressure is actually forming in the tree is that you have these vessel cells and our fiber cells. So now we're looking at a cross section here. And where those two cells meet, that cell wall is actually a semi-permeable membrane. So think of that for those who run a reverse osmosis machine and know reverse osmosis machines, that you have a semi-permeable membrane that has these little tiny microscopic openings that allow water molecules to go through, but your sugar molecules cannot go through. And what happens is, so your sap is within the vessel and moving within the vessel here, but there is some water that will move from the semi-permeable membrane into the fiber cells, because there's more sap full within the vessel cells, and so your fiber cells will fill up with water, but the sugars are not able to go in to the fiber cells. And why that's really important is that now you all of a sudden have this little bit of temperature gradient at the freezing point, because with the sap, there's that little bit of sugar. So the point at which that freezes is going to be a little bit colder, a little bit lower in temperature than pure water will actually freeze. And so for those who concentrate their maple sap in reverse osmosis, sometimes concentrate won't freeze till it's depending on how high the sugars are. But if you have like a 20% uh, sugar concentrate, the freeze point's not going to be till like 26, 27 degrees Fahrenheit. So it's much lower than your typical 32 degrees Fahrenheit for water. And so that little bit of sugar is going to allow the water to freeze first. And what happens is, as that water and you get this little bit of ice barrier, it actually constricts some of the gas that's in the fiber cell. So it actually shrinks that. This image here is showing when it's thawing out, so showing the arrows pushing out as the gas expands. But when it's freezing, it's going to push that gas molecule in and restrict that, because gas can compress, but liquid water cannot. And so that's pushing that and constricting that, making it smaller. It can also sometimes allow more water in from the vessel cell. So that creates that negative pressure as that gas constricts, that allows more water to flow in, that allows the tree to pull up more groundwater and create that kind of vacuum within the tree, which is really important to kind of recharge the trees, to bring up more groundwater, pick up the stored sugars, and create that kind of recharge of sap within the tree. And then obviously when it thaws out, the the ice is going to thaw, that gas is going to then expand, which pushes the water in the fiber cells back into the vessel cells, which is pushing on that gas molecule and causing that pressure gradient, so that increase of pressure to actually form within the trees, which is pushing that sap down and then out of our tap holes then. So hopefully, I mean, that's still a sort of a simplified explanation that's not getting into the mathematical side of things, but that's the real basics. It really has to do with these ability for the water molecules to move into the fiber cells that create that negative pressure to create more room in the vessel cells, and then it's dissolving back into the vessel cells when it thaws out and is pushing that sap, and that creates really that pressure gradient within our maple trees. And we can see this, I already showed I showed those dial gauges, but here's actually a graph from our sensors that we have out, and this is from the Driftless Farms in western Wisconsin. That's looking at just from this past season over a couple days, March 17th, 18th, of looking at the pressure created within the tree in comparison to that atmospheric temperature that we see. As the temperatures warm up, the pressure jumps up in that tree, and then it starts to drop down over time. So our pressure doesn't hold at 25 psi. It'll do that for a couple hours or more, and then it starts to drop down. And as our temperatures dip down and get cold, then we see that pressure drop into the vacuum stage, and then come back up when it warms up. So this is some data from just this past season right in Wisconsin. And so to kind of segue into our Cornell Maple Climate Network that this data was collected from. So this is a project that I've been working on for the last 4 or 5 years now, creating these series of sensors that are collecting kind of maple production data along with their kind of climate data, soil data in real time. And so it puts that online in real time, but also trying to create this kind of long-term data set that'll allow us to answer questions to understand that, how does climate impact maple sap flow or soil moisture? So if we're, having more drought periods, how will that impact our maple sap season? Or, are there things, as I'll talk about a little bit later on, of how can we use this to also help answer some questions
Hey,
about
Adam,
maximizing
can you hear
sap
me?
production. Yep,
I'm not sure if it's just me. I can't hear Adam's audio.
you can't hear me at all right now.
Anybody else having an issue? Oh, you can? Okay. All right. I'm sorry. I'll have to fix my headphone. Didn't mean to interrupt.
All right, that's all right. But as long as everybody can hear me, that's good. So we've been at a couple funding. One was the USDA Agricultural Marketing Service ACER grant, and then the North American Maple Syrup Council funded this for a couple years as well. And we've actually this season are collecting data from seven different locations across the maple industry, from Wisconsin to Maine, one up in Quebec as well. And so we're doing this because we know that climate has a direct impact on maple production, right? So that temperature gradient, creating that freeze thaw cycle is really important for determining our sap flow. Um, so, just thinking about what are some of the things that climate impacts on maple production. So obviously that total production of how much sap do we get. Sounds like most of you had a decent season so far in Wisconsin. And some of you, though, have not had the greatest season. And so that overall production is really important, but also kind of the sap and syrup quality. So does it spike and get up to 70 degrees, 80 degrees in the middle of the season or the first 2 weeks of the season, which some parts of New York I know saw in the first couple weeks of the season, saw some really warm temperatures, which impact kind of the sap quality and potential syrup quality. And what does that do to how clean are the lines and the equipment? Are you getting a lot more biofilm build up in your lines that, from that first 2 weeks that you're going to see across the rest of the season? Obviously, how does it impact your bottom line economically, but then also impacts on outreach where, if you're having kind of some open houses or maple weekends or maple days that, and you don't have, and the sap season's already over, so you're not able to boil, or you're making off flavored syrup at that time frame. And, so this, you have all these people coming into your operation to see the steam boiling and um, the steam rising up as you're boiling, but you're making off flavored syrup. You don't want to be giving out those samples. That doesn't smell that great. So things to think about. So with these sensors, we're working off a LoRaWAN network, which is a low power, long range, wide area network. Working with this company, MCCI, that's the engineering side of things that's building out these sensors for us. We created an early version that had multiple separate sensors that were all battery powered with no solar panel. We had that at the Uihlein Forest, the Arnott Forest, which is our other Cornell Maple Forest, again in the Finger Lakes, and the Proctor Maple Research Center in Vermont. We had those out for a couple years. And then last year we launched into 6 locations from, again, Wisconsin up to Quebec, over to Maine, one down even in Ohio as well. This year we added back in the Proctor Maple Research Center, so we have 7 locations as well. And so it's collecting maple sap flow while under vacuum, which is a really important aspect, I think, to think about sap flow under vacuum. Atmospheric temperature, atmospheric pressure. We're doing tree temperature at 2 different points, the tree pressure, soil moisture and soil temperature at 2 points, relative humidity and precipitation. And so we're collecting sap flow in these vacuum chambers that allow us to maintain a tight vacuum system. And inside of that chamber, we actually have a tipping spoon rain gauge. So instead of measuring inches of rain an hour, we're measuring gallons of sap going through there an hour as well. These systems are all on battery with a solar panel. Here's just some soil sensor, tree pressure aspects. We've had to create a whole data management kind of um, aspect to maintain all the equipment, to collect all the data, to manipulate the data, to know where the data is or all the sensors. And then from there, it gets pushed online to the public dashboard, which anyone can visit at cornellsaprun.com. So it's a real-time dashboard with all the different graphs and figures that are on there that's tracking the real-time data. So there's a lot of engineering and design aspects that had to go into this project. In addition, we're also collecting daily sap sweetness from currently 3 locations. We're open to potentially adding in more spots. This is not automatically inputted. We actually have to manually collect this data and input it into our online platform. But right now, from this season, you can go on there right now and you'll see this graph like this, which shows from the Uihlein Forest, the Arnott Forest, and Vermont's Proctor Maple Research Center as well. So that's interesting to see how does sugars tracking at different locations across the season and potentially look at past seasons. At the Uihlein Forest and Arnott Forest, 2 Cornell Maple Forests, we also look at sap production per tap in our main commercial bush. So what's coming in through our releasers, through flow meters. And so you can use that as benchmarking or kind of see how things are going in different areas. And then based on the sap sweetness, it calculates out syrup per tap. That was data from last season. So if we go back to looking at this data and trying to think, a little bit more about the application and looking at this data from over this couple days at the Driftless Farms right in Wisconsin, looking at atmospheric temperature and tree pressure, and then how does this actually line up with sap flow? And you can see that it lines up quite well. That obviously as soon as our pressure jumps up in the tree, we're starting to see the spike in the rate of sap flow, and as the pressure starts to drop down, that sap flow starts to drop off a little bit as well. And so I just pulled out these couple days for this. Obviously, there's still a lot of analysis that needs to happen with all of this data. And so when we think about, I mean, obviously there's some long-term collecting data and some things that I already mentioned, but think about what is some application of, why is this data important and how can we use this as decision-making tools as maple producers. And so this is, I thought this was kind of interesting. This is some data actually based out of Maine sensor from last season. And I looked at the top rows here are the maple sap production, total sap production over a few different days. And down at the bottom here is the atmospheric temperature. So we see the spikes in temperature, we see the spikes in sap flow, and then kind of dropping down as we go later in the day. And what I found was kind of interesting is that when we look at when the main kind of our heaviest rate of flow tends to be within the first hour, hour and a half, maybe 2 hours of sap flow that we really start to see that we see the heaviest flow. Sorry, on the right here is sap production, but this is cumulative throughout the time period, whereas on the left, this is looking at the flow rate per hour. So that's just each point's the flow rate per hour, how much sap gallons of sap per hour. This is cumulative, how much sap is coming in. We, peaks out at flats, it's because it's frozen. Then the next day it thaws out and it's flowing again. But when we look at looking at these flow rates, we see that the majority of that sap or the heaviest flow is within that first hour. When we're looking at the majority cumulatively, it's within a few hours there. And where the application I think comes in is thinking about on tubing line systems is your tubing system designed to be able to collect that sap within that first hour of when it thaws out, or do you have pitch issues that or a lot of leaks and that your lines are freezing up and you've got an 1.25 inch line that's frozen with sap, and so it's restricting vacuum back to your trees and flow back to your trees. And you're maybe not getting the best vacuum and the best flow during that first hour or two when sap is flowing the best. So that's something to kind of think about when designing your layout and your sap collection, and that the first couple hours I think are really important in making sure we can capitalize on the most amount of sap during that time, and we're not restricting it because our lines are completely frozen up then. And then, so what does some of the other data kind of show from, there is a correlation between the tree pressure, so how much pressure is in the tree, and how much sap flow there is. There's also some correlation with sap flow and atmospheric temperature, not too surprising. Um, and one that we need more analysis over time and looking at more with this, but sap flow and soil moisture. So far, I'm not seeing like a strong correlation, but again, this was just from this one particular year, and I need to look at more of the data set as we build up this larger data set, and we may see that more as we start to interpret that. One other piece I just wanted to mention that's also on the cornellsaprun.com dashboard. If you scroll all the way to the bottom at the Arnott Forest, they have a project from the last 2 years where they've been monitoring sap temperature in different colored main lines. So 4 different colors of main line: white, black, blue, and green. And so monitoring how warm does the sap get within those different colors of tubing, and that's tracked over time. And we see that the green tends to get a little bit warmer, whereas the white tends to stay typically a little bit cooler. The blue was a little bit on the cooler side as well. But we also see that the green kind of freezes up first. So that's kind of interesting to look at that, and that could be helpful for decision making on if you're really cold woods, you may want to think more about black or green tubing that's going to thaw out a little bit quicker. Whereas in a cold wood, you probably maybe would want to avoid the white or blue tubing um, that doesn't get as warm. But also, if you're in a warm woods, you may want to stick more with the white tubing and stay away from green and black tubing. That's going to heat up your sap and have sap quality issues overall. So that's it for what I have prepared on the main stuff right now. Just want to thank all the collaborators who have worked on this project and continue to work on this project. This project would not be where it is without folks like Tony, who's been helping coordinate, and Scott Walter at Driftless Farms for our location right in Wisconsin.
All right. Excellent. Thank you, Adam. That was a really great presentation. I think, I was really enjoying the background info, and then obviously had a really good time participating in this project with you. So I want to just thank you again for coming and sharing your knowledge here with everybody, and then including the Wisconsin Extension program in this project, because I think it is a really fun project, great data to share, and has been a great learning opportunity for us. So it's good to share with the audience here. Want to say the pressure video is really cool. It's nice to have that visual representation when you can just see how the temperature and the pressure are relating in there. And I guess brings up one question from me around snowpack, and thinking about the frost depth and how that impacts sap flows. Can you talk just a little bit about the relationship between snowpack and frost depth and sap flows?
Yeah, it's a good question, and that's, I think, a part that we're hopefully can answer a little bit more, that we haven't analyzed that yet, but that's part of looking at this. But from the literature and science, I think that's out there, more thinking about health of the trees, but then also my own experience. I mean, snowpack for maple trees is generally really beneficial. So there's been several studies now that have actually looked at snowpack and health of trees, and even studies where they've gone out and shoveled off snows for the first part of the winter to remove that snowpack, and then measured how that impacts a tree. And when you don't have that snowpack, what was determined is that you get a deeper frost into the ground, and then that frost heaving ends up ripping the fine roots of the trees, and then you lose total biomass within that tree's overall roots, and so that impacts the overall health. And so not having a good snowpack and you get a deep frost can actually be detrimental to the health of the tree. So obviously as maple producers, we want to have healthy maple trees, so that's not ideal. Um, from a, sap production, I think that having, from what I've experienced and witnessed and talking with a lot of other producers, and that when you have a deep frost into the ground, that it really restricts sap flow out of the tree, that it takes longer for the trees to kind of really get the sap flow to increase. Um, Whereas this past season, I know in Wisconsin, you guys, I believe, did not have a lot of snow from what I've heard from talking to producers. And I have a brother that lives in the Milwaukee area that said there really wasn't much snow this year. So I'm assuming you had a much deeper frost pack. Where in New York, we actually had a decent snow year, and up in the Adirondack Mountains, where the Uihlein Forest is, we had a lot of snow. It was actually really tough tapping this year because the snow was so deep. Um, and it took several days for the snow to kind of melt around the base of the tree in order for them to get flowing, but the ground wasn't really frozen underneath. So once the kind of snow melted away from the base of the tree, the sap flow was pretty decent fairly early on. Whereas areas where if you have, a deep, heavy frost in the ground, it can take a while for that to thaw out in order to get sap flowing.
Hmm. Yeah, we definitely had a lighter snow year, and particularly in the southern part of the state. And there was a real cold frost in February that came through, and without a lot of snowpack. And I think that did delay a lot of folks in the southern part of the state in particular.
Yeah, we
So,
had, and even 3 or 4 years ago now, I know that was kind of, and there was that gradient. So up in, northern New York, we had lots of snow, the ground was insulated, but then in kind of central New York, western New York, where they didn't have a lot of snow early in the winter and they had some really cold weather, so the ground froze kind of deep, and then it took a while for their sap to really start taking off, and their sap was starting to flow, and we like not too long before northern New York started flowing, which is, typically at least 3 or 4, oftentimes 3, maybe 4 weeks behind. When, where I am in Lake Placid, when it finally starts flowing, sometimes they're 3/4 the way through their season and things like that, or halfway through their season. And so, but that year, because they had that deep frost, it took a while for them to get going.
mhm. All right, we got a one question in the or a couple of questions in the chat. I just encourage everybody who's on the call, if you got anything, just feel free to enter it into the chat, or else we could also have you unmute and ask that verbally too. But first question: so, what do you think about adding pipe insulation, like the foam that's used around water heater pipes to help increase sap collection? What do you think about insulated lines and tubing systems?
Um, I would say, I mean, the downside is it's probably not going to totally insulate. So when it gets really cold, it's still going to freeze sap in the lines. And then when, then it's going to take longer for that to thaw out. So my inclination from that aspect, it probably wouldn't be great. It may help keep the sap cooler over time. When you, if you're in a warmer woods and you get that sun and really warm days, that might help keep it cooler. But I think that's a big added expense. That's probably, I mean, depends on the size of your system, and that foam usually doesn't hold up to being outside over for too long, I don't think, and would kind of deteriorate. So it's a great idea, but it's probably not where I would invest my money.
Yeah, that's a good point. And with these monitoring systems that you're deploying, we've got the pressure sensor that is actually in the stem of the tree, and then it's got a little foam attached to it, but it's got a heater element in there so that we can collect the pressure. So yeah, I think without that heater element, the foam is probably not gonna fit,
Yeah.
what you're looking for in terms of fighting that freeze.
Yeah, and that's
Um,
why the foam is on that, in that picture, the pressure gauge, because there's a little heat element in there. Because what we found is that with the sap is in there, there's a little bit of sap. It's a spout with a little bit of tubing and then a pressure gauge. And what we found in the past was that you have some sap sitting there, and when the that sap freezes, and when it's supposed to be pulling and reading vacuum on the tree, which you'd hope, instead the sap freezes and expands and creates this like really high pressure that just shoots off the charts within there. So
Hmm.
that's why we had to put the heater on there overall that for that. I think, you know, going back to as far as sap collection tubing, I think the biggest thing is just trying to make sure your tubing is laid out well, that it's, you know, you don't have dips and sags or freeze points, and you can get the sap out of the woods as quick as possible. If you're thinking about warm weather, and then thinking more about ways to chill down that sap to keep it from spoiling. And so get out of the
Hmm.
woods quickly and then cool it down, whether if need be, whether it's a cooled room that's stored in, you have blocks of ice, or you can put it into a chilled tank. I've been doing some work this past season on some sap chilling and making your own sap chillers. I'll be coming out with a fact sheet hopefully later this spring on more information with that.
Very cool. And I'll just drop this into the chat really quickly. Just a link to the Cornell Maple program homepage, uh, Adam's program website. They've got a lot of really useful tools there, Maple calculators, a whole notebook series. And then I also put a link to the podcast series here, Sweet Talk. So I just want to make sure folks are aware of some of the great resources that are coming out of Cornell for maple producers. And then next question we got is, I think you touched on it just briefly, but could you just revisit how the atmospheric barometric pressure impacts sap flows?
Yeah, so that's we are collecting that data. I don't think I've threw that. I think I actually I had a graph and I took it out this morning that showed atmospheric along with sap flow. The little bit that I've analyzed so far, I'm not seeing a strong correlation, which is a little surprising, but this is actually one of the big things that got me thinking about this project initially, was wondering about that, because there's lots of um you know, thoughts and ideas, and you know, and people have, you know, evidence towards that when they see stronger sap flows, when you have high pressure, low pressure fronts come through and stuff like that, that atmospheric pressure generally, and some people do track that a little bit more. So that it's part of what I'm doing, but I don't have data, I don't have fully analyzed data or enough data to show that yet at this point, but I'm hoping to answer that more.
All right, more to come,
Stay
and
tuned. Yeah.
yep, reasons to stay connected. So next question is about how winter temperature and winter length affects your production. So in terms of sugar content and sap volume, we've got a producer here who's in southwestern Pennsylvania, formerly from Wisconsin, where they sometimes don't have a very long winter. So how does that kind of chilling effect impact overall sap production?
Yeah, and that's something that a lot of maple producing regions are starting to experience more and more, unfortunately. And typically, what we see is lower sugar within the areas when that happens, and part of that is that you don't have the cold weather. That cold weather triggers enzymes to convert the stored starch into sucrose. So the trees photosynthesize, produce sugars as glucose. They store that as starch, and then enzymes actually convert that into sucrose when it's colder. That helps as a freeze defense mechanism in the tree and starts to get that ready for coming out of dormancy. So what we see is you don't get at that much conversion. Um, Also, what I think we see is that the trees are using up more. So anytime, you know, trees are always alive, right? And the warmer it is, the more active, the more cellular respiration, more they're respiring, and whenever they're respiring they need energy to do that. And so anytime your leaves are off, the trees aren't actively producing new energy, new sugars, so they have to use a storage of sugars. And so if your leaves come off in October, but it's still a pretty warm temperatures in the fall that are well above freezing, and then even in, you know, December and January, that it's getting above freezing. Anytime it's getting above freezing, they're going to be respiring and burning up sugars, and so that kind of impacts some of the sap sweetness overall. And I think we've seen that the last couple of years, even in colder regions where we've had some warm falls, that they're burning up some of those sugars. um, that's one aspect, but then how does that impact sap flow? And total sap production. And I think what we're seeing is that people, and especially in those warmer regions, really just need to tap their trees sooner in the season, and that if you're waiting too long, then it's gonna probably warm up and miss out. And also that you might have like these kind of intermittent seasons, and that you might have something in early January, and then you're frozen for a few weeks, and then you might get a couple more weeks. And I think you just have to tap sooner and be prepared for that. Sanitation of, cleanliness of tubing and spouts is really important. So making sure you're using new spouts and new or clean drop lines and things like that. So that that tap hole does not plug up as easily. You can get as much sap. Having vacuum on is really helpful for that as well. And so, in a separate study we've done at our two Cornell Maple Research Forests throughout we did not do it this year, but we did it for 4 years in a row. Before that, we were tapping trees from basically leaf on all the way to leaf off, or sorry, leaf off in October. We're tapping in late October, going all the way to like late April, early May up in Lake Placid, and looking at kind of total dormant season sap production and sap sweetness and tracking that over time. And we did have to go in and retap a couple times throughout the season to be as those tap holes would maybe start to plug up. Um, we would go in and retap. And what was interesting to see when we compare like the Uihlein forest, tapping in the fall really wasn't worth it because we're a colder, and the trees I was tapping is a really cold part of my woods. And so there wasn't that many freeze thaw periods in the fall. We kind of leaves came off. We had a little bit of freeze thaw days, and then it gets cold. And it mostly stays cold through the winter, and we don't get that many thaws, and then it warms up in our major sap run, which is kind of your typical season at the end of winter. But at the Arnott Forest, like they were making sometimes equivalent of like a quart of syrup in before Christmas. And so I think in some of those warmer regions, there's merit in thinking about tapping sooner, even before Christmas time, of and collecting at those time periods. And maybe even thinking about maybe tapping half your trees in the fall and half in the January, where you kind of hedge your bets one way or the other, depending on what the season's gonna do overall. So it's a little bit trickier in those areas, unfortunately. But there's ways I think around it overall that we can kind of try to do the best that we can.
Yeah, that's a really helpful answer. And we got another question in here that kind of relates to that. And the question is it normal for taps to dry up after a few weeks, requiring fresh taps to get flow again? And you mentioned that, and it's a lot to do with hygiene and then some, potentially the temperatures, but I'll let you know.
Yeah, 3 weeks is a little short, I would say, but it depends on how warm the temperatures were. Again, like if you had some 70-degree temperatures, then early on, then that's maybe not that abnormal, but some of that might have been and not, knowing what the person's doing, but again, having sanitized or new spouts, if you're using tubing, making sure that that's cleaner and putting vacuum, keeping in vacuum, so preventing some of that sap from sucking back up into the tree could be part of it. If you're on buckets and you hit a couple days of 60-degree, 70-degree, or even 50s early on and stays kind of warm, that could certainly happen. It's not typical to dry up that quickly. I will say, going back to, I mentioned the retapping, we were actually going vertical on the tree. In theory, trying to think about that we're not creating as much more compartmentalized wood, although University of Vermont did a study where they found that it does create more compartmentalized wood when you do that, but at least you're within the same column, and that's not wood you're going to be tapping within the next few years anyways. But you got to make sure you plug the old tap hole, because that would be a vacuum leak. But
Mm-hmm.
you can also move to other sides of the trees. And what I find is, again, in my forest, it's a pretty short growing season. We're more of a zone 3, and so we have a short growing season. Our trees don't grow that quickly. So retapping and putting more holes in is maybe not the best thing. But if you're in a warmer climate and your trees are putting on a lot of growth every year, then maybe putting a second tap hole to retap that, whether you're going vertically and plugging the old one or shifting to another side of the tree. Maybe it's okay because your tree's going to keep up with that growth.
Mhm. Okay. All right. We just got a couple more questions in here. I see one question that's about sanitation. So I'm just going to add a blog post that we recorded a maple hour last year that talks about all of the kind of best practices for end of season sanitation, including tubes. But while we got you here, Adam, uh, one question is about what would explain the differences in sap production between closely neighboring trees or even two trees on or two bags on the same tree.
So biggest one would be making sure you're each tap, if you're in the same tree, you got two spouts with two bags or buckets on the same tree, that you're into good clean wood, that you didn't hit some kind of wounded or compartmentalized wood that's there. So making sure that when you're drilling a tap hole, you want to be looking at the shavings coming out, and they should be a nice kind of creamy white color of the shavings. If you're getting like a darker tan or brown, then you're getting into whether some compartmentalized wood from old tap holes or any kind of wound within that tree. So that could be part of it, or you're just a seam or cavity within the tree that could be part of it that's impacting. That would most likely be my guess if they're on the same tree. But as far as referring to neighboring trees, that still applies, making sure you're getting good clean tap holes. And also making sure that those spouts again are clean and sanitized equally between the two of them. And but as far as like tree to tree, trees vary. Some genetically just produce more than others, but size of your tree, size of your canopy, health of your trees. So generally larger trees produce more sap. But that as long as they're healthy trees, but what I like to think about more is bigger canopies produce usually more sap and sweeter sap because there's more branch, there's more volume of wood. That can store that sap. But also when you have bigger canopies, you have more leaves. More leaves are going to produce more sugars during the summer growing season, which is going to give you sweeter sap in general as well. So that's going to be a big difference. So generally, the bigger the tree, the more sap you'll get. But then there also gets to the point where you're starting to get a tree that's not as healthy and it's dying off and it won't be as great. And it could also be another thing I'll say about especially the two taps in the same tree, the orientation in that tap hole that's like on the south side is going to thaw out first and start flowing sooner. And then your north side tree, which is going to be a little bit cooler, and not flow as quickly. Generally at the end of the season, that equalizes out because that later in the season, that south side tap hole is going to dry up first before the north side tap hole. And usually they work out to be the same. So I'm not saying go tap all your trees on the south side, because that would just create a lot of wounds on one side. We want to move around the tree, but that could be the reason too. It's just what side got a little more sun and maybe had a little more flow, but then later on the season, that tap hole could be drying up compared to the other one.
All right. We are just about at the top of the hour, so I am going to